Jai Shri Gurudev. In our last YouTube classes, I completed your second year topic chemical kinetics. On this session, I am going to introduce your second year another topic electrochemistry. The name itself tells that the electrochemistry means it's a study of interconversion of your electrical energy into chemical energy and chemical energy into electrical energy. Now it is defined as electrochemistry is a branch of science which deals with the study of interconversion of electrical energy into chemical energy and chemical energy into electrical energy. Interconversions. Now, in this electrochemistry, there is a several cells or devices which should be used to convert electrical energy into chemical energy and chemical energy into electrical energy. That device will be called as an electrochemical cell. Electrochemical cell means it is one of the device which convert electrical energy into chemical energy and chemical energy into electrical energy. This electrochemical cell classified into two types. One is galvanic cell, another one is electrolytic cell. Your galvanic cell is also called as an voltaic cell. In this galvanic cell, it is one of the devices. The here cell means it's a battery, it's called as a device. The galvanic cell is one of the electrochemical cell which convert chemical energy into electrical energy. The device which can only convert chemical energy into electrical energy, that device will be called as a galvanic cell as well as your voltaic cell. Electrolytic cell means it is a device which can convert electrical energy into chemical energy. Example for your galvanic cell is Daniell cell. Example, this is about your basic introduction of your electrochemistry. Let us see construction and working of your Daniell cell. Before going to know about your construction, first you can analyze the two terms is very important. One is metal rod. Metal rod. For example, let us consider the zinc metal rod. This metal rod dipped into solution of its own ion means it dipped into solution of own ion means zinc sulfate. Zinc rod, zinc metal rod dipped into its zinc sulfate solution, and another metal I will consider the copper. Copper rod is dipped into an copper sulfate solution. In this metal rod will be called as an electrode. This solution will be called as an electrolyte. This is also called as an electrolytic solution. Metal rod will be called it as an electrode, and it dipped into an solution of its own ion, it is called it as an electrolyte. This is the two terms is very important. So now let us see the construction and working of your Daniell cell. Let us consider two electrode. One is zinc electrode, another one is copper electrode, in which your zinc rod dipped into zinc sulfate solution, your copper rod will be dipped into copper sulfate solution. Both the metal will be connected to an voltmeter by using wire. Now, if the two electrolytic solution connected to an salt bridge, this is your construction of Daniell cell. Zinc rod dipped into an zinc sulfate solution, copper rod will be dipped into copper sulfate solution, both the metal electrode connected through an voltmeter, and the solution, electrolytic solution, connected through an salt bridge. The salt bridge is a U-shaped bridge, U-shaped tube, which is made up of the agar-agar hot gel is mixed with along with the KCl as well as ammonium nitrate, or else this U-tube consisting of a standard solution of an KCl or ammonium nitrate solution. This is the one jelly type mixture. The both end of your U-tube will be and make it as some porous material, filled with some porous material. This is your construction of your Daniell cell. This is about your salt bridge. Now, if the potential of this Daniell cell will be 1.1 volt, if the electrode potential of this Daniell cell will be 1.1 volt, if the concentration of the solution make it as unity, it means the solution concentration should be 1 mole per dm cube, then this electrode potential of this chemical cell is equal to 1.1 volt. Now, suppose we can imagine that we can apply the extra potential for your Daniell cell. The three cases will be possible. If the electrode potential of Daniell cell is 1.1 volt, now your extra potential will be applied, which should be greater than 1.1 volt. This is the first case. Second case, your extra potential equal to 1.1 volts. Your third case, you are applying extra potential which is less than 1.1 volt. These are the three cases your Daniell cell behaves in the different way by losing as well as gaining of the electron. This is about your Daniell cell construction. In Daniell cell, it is having the 1.1 electron potential. Now, if the current is applied for this Daniell cell, the current flow in one direction. If the current flow on this direction opposite to that of the current flow, electron will be flow on this direction. It's meaning that in both the electrode there is some potential difference. If the electrode that is having a potential difference, then only there is a flow of a current. If the electrode potential of the two electrode will be same, there is no flow of current will be takes place. Now, if the current will be applied for this one, the current flowing from copper to zinc, and similarly the electron flow opposite to that of the current, if the electron flow from zinc to copper. Now, if the potential difference exhibit between this is called as electrode, this is called as an electrolyte. The potential difference exhibit between the electrode and the electrode will be called as an electrode potential. Now, this potential difference, this electrode potential difference will be denoted like this. Zinc is the metal dipped into an zinc sulfate. This is the representation of your metal and their solution, electrode and their electrolyte. It is also written as zinc rod dipped into zinc sulfate solution. In this, the potential difference of copper and solution is represented copper dipped into copper sulfate. This line indicate the difference phases between the metal and their solution. This is also written as copper rod dipped into copper sulfate solution. Now, flow of current will be takes place. Opposite to that, the electron will be start on flowing. Suppose concentration of this solution will be maintained unity. This system becomes an extra potential should be 1.1 volt. Now, this overall Daniell cell can be represented like this. Zinc rod is a metal dipped into zinc sulfate solution. Both the solution, this two solution will be connected with the two solutions connected with the salt bridge. This salt bridge will be represented as the double line. Dipped into copper sulfate solution, which is connected with the metal, that is copper. This is called as a Daniell cell representation. Zinc rod dipped into an zinc sulfate. This solution connected to an salt bridge with the copper sulfate solution. Then it is connected to an copper metal. Now, suppose your extra potential is applied less than 1.1 volt. You should increase the potential for the Daniell cell 0, 0.1, 0.2, 0.3 like this. Less than 1.1 volt. Your zinc electrode will ready to lose the electron, start losing the electron. To loss of those electron, our zinc will undergo oxidation. Zinc will easily undergo oxidation. If the oxidation takes place in the galvanic cell, the electronegativity species of the negative charge of the electron increases on the surface of the metal. Therefore, it is called as an anode, which has got a negative sign. Negative sign is because if the electron will be released from zinc to an copper, zinc to copper. Now, the cloud of the electron on the surface of the metal will be increases. It takes place with a negative sign. That's why it is very important to undergo oxidation, and if the oxidation takes place in the galvanic cell, which is called as the anode, it denoted with the negative sign. Very important, not positive. Anode is positive. Here, based on the losing as well as gaining of the electron, I will introduce as anode as well as negative sign. Here, zinc will start again losing the electron. Zinc lost the 2 electron, converted into Zn2+. Your copper will start accepting the electron. It's meaning that it undergo reduction. If the reduction takes place, it is called as an cathode. It denoted with the positive charge. Your copper will start accept the electron, converted into copper. Your copper will be start depositing on this metal surface. Now, from this, zinc will start disappearing. Disappear means it decomposes into a solution by giving the electron. Here, copper will be start accompanying. It will be on the surface of the metal. It will be start accompanying the surface of the metal. Now, from this cell, it is clear that our zinc electrode potential will be totally different from the copper electrode potential while connecting these two and salt bridge. Here we have to use a salt bridge because of transferring of the electron should be very easy. The electron potential of the your whatever the solution you should use it in the your salt bridge will be same as the your electron transfer from zinc to copper. Now your zinc will start losing the electron and copper will be start and gaining the electron. During the loss of electron will be called as oxidation. If the oxidation takes place in the electron will be called as an anode. It denoted with the negative sign. apply extra potential until reaches to 1.1 volt. Your extra potential equal to your Daniell cell potential. It's meaning that 1.1 volt. In this circuit, there is no current flow and no electron transfer on this circuit. It should be a constant. If the potential will be reaches to exactly 1.1 volt, there is no current change. I is equal to 0. There is no current flow at all. If the no current flow, no electron transfer from zinc to copper. This is the extra potential equal to 1.1 volt. Now, if the extra potential should be applied for your Daniell cell, if greater than 1.1 volt, if less than 1.1 volt, the electron flow from zinc to copper. If the greater than 1.1 volt, your Daniell cell behaves like your electrolytic cell. It's meaning that the copper will donate the electron, zinc will accept the electron. If the extra potential should be greater than 1.1 volt, if the electron flow from copper to zinc, and current will be flow from your zinc to copper. The opposite, your Daniell cell should behave like your electrolytic cell. Now, from these three cases, we can clear that our Daniell cell, whatever the potential will be there, 1.1 volt, less than 1.1 volt, if the electron move from zinc to copper, equal to 1.1 volt, there is a no flow of current, no flow of an electron will be takes place. If greater than 1.1 volt, the electron flow from your copper to zinc. Now we can give the net cell reaction for your Daniell cell. Net cell reaction is like that. Our zinc will capacity to lost the electron and converted into Zn2 plus. Losing of electron, it's meaning that oxidation. Our copper will having tendency to accept the electron and converted and deposited as an copper. It's meaning that it is undergo reduction. Its two reactions clearly indicate that in our Daniell cell both oxidation and reduction should be takes place. It meaning that our Daniell will cell undergo redox reaction should be takes place. The overall cell reaction should be given as Zn Cu2 plus is raised to Zn2 plus Cu. This is the cell reaction. If the two cell, which is one is undergo oxidation, another one undergo reduction, that cell will be called as half cell, individual cell. This is the individual cell. This is called as individual cell. This is called as an half cell, which is undergo oxidation, which is undergo reduction. If that is called as an half cell, the net potential will be called it as between the half cell will be called it as a cell potential. This is the overall cell reaction of your Daniell cell based on the oxidation as well as reduction. Now, let us see electromotive force. It's denoted with a symbol EMF of a cell. EMF of a cell exhibit only the potential difference between the two electrodes. It clearly indicates that if the current flow from one electrode to another electrode, if the potential difference between the two electrodes will be not same. If same, there is no current flow, there is a no flow of an electron will be takes place. In this, electromotive force as well as EMF of a cell, meaning that when the flow of an current from one electrode to another electrode will be called it as an electromotive force. It is called it as an cell potential. It denoted with the letter E. This is also called as electrode potential. Now, electrode potential means the flow of an current from one electrode to another electrode ಅಥವಾ higher potential to an lower potential, one electrode to another electrode, anode to cathode will be called it as an cell potential. This cell potential is denoted with the E cell, E as well as E cell. It is also, your electrode potential will also define in the form of standard form. Standard electrode potential as well as standard electrode potential as well as standard cell potential is denoted with the letter E naught of a cell. Standard means if the flow of an current from anode to an cathode in the galvanic cell, it should be maintained with the unit concentration as well as unity in activity. Unit activity li now maintain madadaga that condition will be called it as an standard condition. The concentration should be maintained, should be unity, as well as the unit acidity will be maintained, that will be called it as an standard electrode potential.